Welcome back, Titans. And we're going to start the second semester off talking about exponents. And so in lesson 8.1, we'll define exponents and powers, we'll find products of powers, and simplify products of monomials. First, the definition of an exponent. As you can see, the x to the m means that the base of x is a factor m times. And so in the visual over here, we can see that 2 is the base, 3 is the exponent, and that whole thing is called the power. And so 2 to the third would mean 2 times 2 times 2, which would equal 8. We also want you to make sure of down here that if the exponent is 1, or if there's no exponent, the exponent is understood to be 1, which means the base is used as a factor 1 time. So if we look at multiplying powers, if we have x to the third times x to the fourth, well, by the definition of an exponent, x to the third would mean x times x times x. X to the fourth would mean x times x times x times x. And since they're being multiplied, then the total number of times x is used as a factor is 7, so it's x to the 7th. If we look at a to the 5th times a to the 6th, a is a factor used 5 times. Then a to the 6th means a is a factor used 6 times. And so a is used as a factor a total of 11 times. So it's a to the 11th. So what is the shortcut? Well, if I have c to the 12th times c to the 15th, instead of having to write down c as a factor 12 times and c as a factor 15 times, hopefully you're able to recognize that we could add the exponents as long as the two bases are the same, and our answer would be c to the 27th. So to multiply powers that have the same base, we simply keep the base the same and add the exponents to find. So the definition. So for all non-zero real numbers x and all integers m and n, if we are multiplying two powers that have the same base, we keep the base the same and add the exponents. A monomial is kind of a complicated word for a very basic expression. A monomial can be just a constant, so just the number 5. It could be just the variable, say x, or it could be a product of a constant and one or more variables, maybe 5, x squared, y. Then the coefficient is the numerical factor of a monomial. And so in this last example here, 5 would be considered the coefficient. To simplify a product of monomials, the steps we'll use is you would remove the parentheses and use the commutative and associative properties of multiplication to rearrange the terms. Group constants or coefficients together and then group like variables together. And then simplify by using the product of powers property where appropriate. So, simplify the product of monomials containing the exponents. Well, in this case, we have 5c squared d to the third times 7c d to the fifth. So we remove the parentheses, we group the coefficients together, 5 times 7, and we're going to group the variables that have the same base together. Notice that the second c has an exponent of just 1. Now we add the exponents of like bases. We multiply the coefficients for our final answer of 35 c to the third d to the 8th. Now, these are examples of just here evaluating an exponent. So 2 to the 6th, again, by using the definition, that's 2 times 2 times 2 times 2 times 2 times 2. So this ends up being a total of 64. 4 to the third, which is 4 times 4 times 4, in this case, is also 64. 10 to the seventh, well, to take 10 and raise it to a power, you just add that many zeros. So I put the 1 down, then I'm going to add 1, 2, 3, 4, 5, 6, 7 zeros. Put in my commas, and so that would be 10 million. And then 8 to the first power is simply 8. These are for examples 34 through 43 in our book. And again, we're just using the product of powers property. And notice in this first example, the bases are the same, so the base stays the same, and we add the exponents. So that'd be 3 to the sixth. In number 2, again, the base stays the same, and we add the exponents. Number 3, when it's variables, we seem to pick this up really quick. The base stays the same, and we add the exponents. Notice that in 1 and 2, the bases were numbers, but they still stayed the same. 3 to the sixth, 8 to the fourth, as we did here in B to the ninth. And then in example 4, the base would stay the same as A, but we're adding those exponents. Well, W and 3, well, they're not like terms, so we have to write it as a sum, W plus 3. And here's multiplying monomials. So we're going to use the steps that we talked about before. So we're going to group 3 times 60. Then we're going to put the m squared times the m. And we have just the p squared. And so if we multiply these together, 3 times 60 is 180. Then we add the exponents, m to the third and p squared. And we look at this last one, we'd have 8 times negative 10 times negative 2. Then we'd have just the x. Then we have a y times a y. And we have a z times a z squared. Now to simplify this, 8 times negative 10 is a negative 80 times a negative 2 is a positive 160. X, we'd have y, both of them are to the first power, so that's y to the second, and then z to the third for our final answer. I'd like you to pause the video here after this and work on these next problems. After you've worked them, then begin the video again to check. If you have your book, you can open it to page 374, 6 through 17, and work the following problems. If not, they'll be shown on the next slide. So again, here's where I would pause the video and work these problems. And after you start it back up again, the next slide will then show you the answers. And again, take an opportunity to pause the video, check your solutions, and just see how well you did. And come with questions tomorrow that you can ask. Anything that you don't quite understand. All right, and that will conclude our lesson over multiplying monomials and the products of powers property. Have a good evening.
Made with Doodlecast Pro.